Okay, so page 2. For number 13, only difference is that we need to get all terms on one side. So I had to move the x over, so I subtracted x. I have to move the 8 over, so I have to subtract the 8. And then, because nothing's left on the right, that's why we have equals 0, right? So we end up with 12x squared plus 6x minus 6 when we move everything to the left-hand side. Now be careful. Always look for a GCF first. You can divide 6 out of all 3 terms, so that is our GCF. Sometimes you can then go further and factor the trinomial remaining. Pretend that all we see is this yellow box, this trinomial, where A is 2, B is 1, and C is -1. So we come up here. What multiplies to A times C, or -2, that adds to 1. The combo is 2 and -1. So we put those right here. Remember, this yellow box, this yellow trinomial we're working on, the front number of this trinomial is 2. Therefore, these factors have to go over 2. Simplify, swing out. So we get x plus 1, and then we simplify 1/2. The 2 swings in front. So the yellow box turns into this expression, x plus 1 times 2x minus 1. And the left ends, 2x times x, get us 2x squared. Okay? Notice, we still leave that GCF of 6 hanging out in front. And then you set your parentheses equal to 0 and solve. So when we set x plus 1 equal to 0, that's how we got -1. When we set 2x minus 1 equal to 0, that's how we got 1/2. You should always have 2 answers if it's degree 2. Now notice for number 14, all you could take out was a GCF. So there was a GCF of 3, but then the trinomial that was left, you couldn't factor any further. And based on what we know, since we haven't reviewed the quadratic formula, we're going to say that we can't find the solutions by factoring, okay? But there are solutions, but we'll stop there. Number 15 was a little tricky. Now first off, look at the degree. You know the degree is 2, so you know there need to be 2 answers. Your variable is n. You should have 2 answers, degree 2. You always get everything on one side, check. 0 on the other, check. You always first look for a GCF. The GCF, you can either take out 4n or -4n. You will still end up with the same answer. So if I take out -4n as a GCF, I'm left with 4n plus 3. You then set each factor, the GCF is considered a factor, equal to 0 and solve. That's why we end up with n is 0 and n is -3/4. A lot of you got n is -3/4, but I bet some of you forgot n is 0. Remember, there's 2 answers, so if you only have 1, go, oh yeah, the GCF in front, if it has an x or a variable, that's why I have a second answer. That's where it comes from. Okay, so the word problems are always kind of tricky. It says that we have an old stage that's 30 by 15. So that means the area of this guy is 450 square feet. But then it says we want to make a new stage. Obviously your new stage, they're saying you're adding on, so it should be area. They're saying the area of the new stage is 1,000 square feet. Area always equals length times width. So this is an expression. Ask yourself, if I make a bigger stage, what's the new length? It's not going to be 30 because you're adding on. So the original length of the stage was 30. This is where you're using your geometry, but you're adding a little more on here and a little more on here. So the green, 30 plus x added plus x added for the length gets you 30 plus 2x. This is the length, 30 plus 2x. The new width when you add on is the original, plus you add a little more on both sides. So this is the new width. And then from there, it's you just have to solve. So you distribute, you get all your terms on one side, write it in descending order. You always want the squared, the x, and the constant to go in order. And then you factor. So I took out my GCF of 2. Then, yeah, the numbers are big, but I'm looking for a combo that multiplies to 2 times negative 275. That adds to 45. So my combo was negative 10 and 55. So then what I did is I put it over the front number of the trinomial I'm factoring. The front number is 2. That's the trinomial I'm factoring. Simplify, swing out. And when we do that, we would get x minus 5 times x plus, 2x plus 55. And if you set both to 0, you get 5, and you get negative 55 over 2. We're adding on x units, so it's got to be positive, and we'll insert feet. So we're adding on 5 feet, all parts. Okay, so this last one's a little tricky as well. You guys know area is length times width. That becomes a repeating situation. Now, what we're going to do, they say the whole area. So the picture, including the frame, the whole area is 5 square feet. But then they say the picture area is 4 square feet. So the area of the frame is the whole minus the picture, 1 square foot. Now, to find the frame, we're kind of going in reverse. Length times width. So we look at the length. The long length is x, but we have to subtract out the picture. That's why it's x minus 2, the length of the picture. So that is the length. The whole, which was x, but we minus out 2 for the picture. That's our new length. Similarly, for the width is the whole length x minus that picture 2. Then from there, that's the hardest part. You FOIL, you get all terms on one side. Then when we factor, we get x minus 3, x minus 1. Set those to 0. So we set each of those to 0. And we get 3. And we get 1. Now a lot of you think, oh yeah, my positive answers always work. Now go back to this image. It says, what's the length of the sides of the frame? So x is the side. If we know the picture is already 2 feet, right? If we know the picture is 2 and we're trying to see how long this whole thing is, obviously it can't be 1, can't be smaller than the picture. The frame needs to be larger. So our answer is 3. 3 feet is our answer. If you have questions, if I'm not in the math office, by 8:10 tomorrow, you can ask another Algebra 2 teacher, Miss Ayad, Miss Lee, they're usually there early. Or if you have your math assessment after break, you can come into the math office at break in room 234. So there's always a teacher there to help if you have questions.